What is folk psychology? Imagine you're at a party, trying to decipher why your friend suddenly stormed out. You might instinctively analyze their behavior, attributing it to their beliefs and desires. This everyday ability to understand others' minds is like a puzzle, and philosophers and psychologists have been intrigued by it for ages. Enter theory, the idea that our understanding of people's actions is akin to using a scientific theory. It suggests we mentally model others, attributing beliefs and desires to explain their behavior. It's like playing detective in our social interactions, trying to piece together the motives behind each action. But hold on, not everyone buys into this theory. Some argue that folk psychology, our intuitive way of understanding others, is more like a handy tool than a full-blown theory. It's the difference between being Sherlock Holmes and just making educated guesses based on past experiences. Now, picture a mental module, a specialized tool in your brain dedicated solely to understanding other people. This is where modular theory comes in. It suggests that our ability to grasp others' minds is housed in this unique cognitive gadget, either inherited from our ancestors or developed through our life experiences. Whether you see folk psychology as a Sherlock-esque investigation or just a handy social toolkit, it's undeniably fascinating. After all, it's what helps us navigate the complexities of human interaction, and that's a puzzle worth solving. Let's dive into another fascinating theory about how we understand each other's minds: scientific theory STT. Instead of viewing folk psychology as a set of fixed beliefs, STT suggests it's more like a constantly evolving theory, and get this, even kids are like little scientists in this process. Imagine children as budding researchers, gathering evidence from their experiences to build and refine their own theories of how minds work. They're not just passively absorbing information, they're actively testing hypotheses, learning from trial and error, and even from what others tell them. As they grow, kids tweak their theories based on new insights and observations, gradually developing a deeper understanding of concepts like belief. For example, by age 4, most children grasp the idea of false beliefs, understanding that someone can believe something that isn't true. But wait, there's more. Another spin on theory is model theory. Instead of seeing folk psychology as a rigid set of rules, it's viewed as more fluid, like building mental models of how people think and feel. These models help us predict behavior and explain why people do what they do. So, whether we're tinkering with theories like young scientists or mentally modeling the minds of others, it's all part of how we make sense of the social world around us. And the best part, it's an ongoing adventure of discovery. Mybaum, 2009, argues that Model TT is well placed to explain how we manage to apply a TOM sensitively by adjusting to supporting, context-sensitive knowledge that cannot be supplied by a core TOM itself. In her view, Model TT can explain how it is possible to apply our TOM sensitively in ways that address the particularities of specific cases. The idea that our everyday TOM abilities depend on the use of a set of adjustable subpersonal models, as opposed to a fixed set of propositions describing FP laws, fits well with predictive processing accounts of cognition, Gopnik and Glimor 2002. Predictive processing accounts of perception hold that, at its core, such cognitive activity always takes the form of making inferences concerning the hidden causes of sensory phenomena, Hoey 2013, Clark 2016. Advocates of the predictive processing variants of TT hold that the processes used in FP are of the same basic kind used elsewhere in every other variety of cognition, including acts of basic perception. The only difference is that in the case of FP the target of the activity is to infer how other minds cause actions. See, e.g., Gopnik and Wellman 2012, Bowers and Davis 2012, Koster Hale and Sachs 2013, Hoey and Palmer 2014, Palmer, Seth, and Hoey 2015, Pizzulo 2017, Zednik and Jackal 2016, Hara Ettinger et al. 2016, Hara Ettinger 2019. Making inferences about other minds can be understood as a matter of solving an inverse problem, that of using observable evidence, in this case, behaviors, to infer the invisible causal structure that produces it, in this case, presumably, mental states. Proponents of Model TT are free to assume that the models used in this process are complex, operating simultaneously on multiple scales and levels. In line with predictive processing assumptions, it is assumed that models improve over time through the sustained effort of minimizing prediction error by adjusting predictions in response to mismatches between the content of top-down hypotheses and bottom-up information. Like all other versions of TT, an animating idea behind Model TT is that the subpersonal work of brains is roughly analogous to what scientists do when making inferences in their efforts to best explain phenomena. The assumption is that brains develop generative models that enable them to advance hypotheses, and those hypotheses are further developed, refined, and improved by being tested against what the world has to offer. For all their promise, Model TT raises important questions that need further attention. These include: what is the evidential support for such accounts? Stuhlmuller and Goodman 2014. What should we make of their metaphysics? How seriously should we take the idea that brains actually advance hypotheses and perform subpersonal modeling operations? Slors 2012, for example, warns of a tendency to think that TOM attributions are ubiquitous even in the face of challenges posed by those who believe that the best explanations of RFP abilities do not involve theorizing of any kind, at any level. See section 4.3. According to Slors's diagnosis, those who fall foul of this temptation commit the model-model fallacy. He holds, the model-model fallacy occurs when a theorist systematically uses TOM models to describe what are, in fact, non-mentalizing social cognitive processes. Though doing so may be valuable for various useful theoretical or practical purposes, those who fall foul of this fallacy systematically conflate features of the TOM models themselves with what goes on subpersonally when exercising RFP competence. 3. Empirical findings. 3.1 Comparative psychology. An important topic that has been hotly investigated is whether FP is an exclusively human ability or one shared with other non-human animal species. Empirical studies investigating TOM capacities have been conducted with many species, including bottlenose dolphins, corvids, ravens, scrub jays, and dogs. Daly, Emery and Clayton 2006, Tomonaga et al. 2010, Bugnyar and Heinrich 2006, Bugnyar, Reber, and Buckner 2016, Wyden 2013, Maginati and Grace 2014, see Lurs 2011 for a book-length overview of mind reading in animals. The most sustained experimental work on animal FP capacities has centered on the social intelligence of non-human primates. In 1978, when the debate was just kicking off, Premack and Woodruff launched a small industry by asking in their seminal paper, "Does the chimpanzee have a theory of mind?" Early assessments gleaned from anecdotes of the behaviors of individual animals seemed to return a positive answer to the titular question. Byrne and Wyden 1991. Subsequent, more controlled, experiments raised questions about that verdict. In naturalistic settings, non-human great apes exhibit impressive social intelligence. Byrne and Wyden 1997, Suddendorf and Wyden 2003. Despite this, experimental findings are equivocal about whether, to what extent, and in what ways they are aware of other minds. Initially, there was only negative evidence that chimpanzees and orangutans understand the concept of belief, even when tested by simplified non-verbal versions of the location change, false belief tasks. Povinelli and Eddy 1996, Povinelli 1996, 2003, Call and Tomasello 1999, Penn and Povinelli 2007. Switching from a cooperative to a competitive design in their task protocols marked a turning point in the field. Hare, Call, and Tomasello 2001. This change of testing regime yielded evidence that apes may be aware of simpler mental states other than beliefs, such as seeing. Even so, that evidence is equivocal. The results are decidedly mixed. Call and Tomasello 2005, 61. A safer conclusion at this stage of inquiry is that simian capacities for engaging with other minds exhibit signature profiles that differ in important respects from that of adult human beings, and even that of human infants. The dismal performance of chimpanzees on the standard human variants of non-verbal false belief tasks, which test the subject's capacity to understand that beliefs can be false, galvanized a widespread agreement that the social cognition of great apes does not depend on a sophisticated capacity for FP, certainly not one based on their having an understanding of belief and interrelations between that concept and other canonical mental states. Call and Tomasello, 2008, highlight this fact when revisiting Premack and Woodruff's Big Question 30 years later. Concluding their review of the field, these authors tell us that while the evidence suggests that, in many respects, chimpanzees do have some grip on other minds in many other respects, it also tells us that they do not. Comparing the test results for apes with those of human children has all but secured the conviction that if apes do have any FP abilities, then they are not of the same form or in the same degree as that of humans. The live issue today is not whether chimpanzees or other non-human animals make use of a fully developed FP, but whether they have any degree of mind-reading ability at all. Ethologists and primatologists have shifted their focus in this new direction. The main questions now occupying the field are: how do apes and other non-human animals manage their sophisticated social interactions without the capacity for full-blown human-style FP understanding? And, if so, what form does their everyday grip on other minds take? The gap between evidence and theory generates a logical problem in the interpretation of empirical data, which poses, some argue, an insurmountable challenge for anyone hoping to establish the truth of TT based on empirical findings. Whiten 1996, Povinelli and Vonk 2003, Lurs 2009, 2011, Buckner 2014. This problem arises because there is always logical room for characterizing and explaining evidence concerning FP capacities in deflationary non-TT terms. The logical problem reminds us that positing toms, of whatever number and type, is not the only live theoretical option for characterizing or explaining the relevant empirical data. Not everyone is pessimistic about overcoming the logical problem by purely empirical means. Hayes 1998 suggested this might be done by finding evidence of subjects projecting first-person experiences onto others. Some researchers find this protocol promising and seek to develop it. See Southgate 2013, Kano et al. 2019, Lurs and Kraken 2019. There is now a range of proposals about how best to characterize the apparently FP abilities of non-human apes and other animals. Within the TT camp, the axiomatic assumption is that an everyday understanding of minds essentially involves attributing mental states by employing some kind of tom. It is accepted, however, that the toms in question need not be identical to the fully fledged version of FP used by adult humans. Under the TT umbrella, it has been proposed that non-human animals may be using a naive, weak, or minimal theory of mind. Bogdan 2009, Apperly and Butterfield 2009, Perceptual Mind Reading, Bermudez 2011, or an early mind reading system, Nichols and Stitch 2003. Others favor the idea that animals only simulate the effects of mind reading. It has been proposed that certain feats of social cognition might be variously carried off by a sophisticated theory of, or special sensitivities to, behavior. Povinelli and Vonk 2004, Gallagher and Povinelli 2012, Submentalizing that utilizes domain general non-tom processes, Hayes 2018, though see Kano et al. 2017 for a challenge mind-minding abilities that target but do not attribute mental states or contents, Fenici 2013, 2015, 2017, Hudo 2017, see Hudo, Hirschbach, and Southgate 2011 for a discussion of non-mind reading proposals. Another interesting possibility is that non-human animals, like human children and adults, could be using a much more diverse mix of strategies and tactics to enable their everyday understanding of minds than imagined by FP traditionalists, see section 4.4. 3.2 Developmental Psychology. There exists a substantial body of research on the development of folk psychological abilities in young children. A range of findings in developmental psychology reveals how younger children perform in experimental settings when it comes to their dealing with a wide variety of everyday mental states. For example, at around 2 years of age, children are sensitive to the fact that different people have different goals and desires. Wellman and Phillips 2001, Barch and Wellman 1995, Rapakali and Gopnik 1997. A 2-year-old's understanding of desires can be rather sophisticated. Children understand, for example, how desires relate to emotions and perceptions, and what would relevantly and consistently satisfy specific desires, exhibiting some fluency with counterfactual thinking of a limited sort. As impressive as these abilities are, they neither equate to nor entail an understanding of belief, and it is testing for belief understanding in younger children that takes center stage in child developmental research on TOM. Testing for an understanding of belief is deemed by many to be the empirically robust, gold standard way of ascertaining the presence or absence of TOM abilities. The false belief test or FB test, sometimes referred to as TOM test, was first constructed by Perner and Wimmer in 1983, and the experimental protocol has been further modified by others. It now comes in many subtly different variants, including location change tasks, unexpected contents tasks, and appearance reality distinction tasks. See Wimmer and Perner 1983, J. Flavel, E. Flavel, and Green 1983, Baron Cohen, Leslie and Frith 1985, Perner, Leakham, and Wimmer 1987. In the original test of young children's grasp of false belief, participants were introduced to a puppet, Maxie. The participant watched as Maxie's mother put Maxie's chocolate in cupboard X. In Maxie's absence, the mother moved the chocolate to cupboard Y. When Maxie returns, participants are asked where Maxie would look for the chocolate. Significantly, no participants in the 3 to 4 year range answered correctly. A familiar explanation of these findings is that those who fail these kinds of FB tests lack the concept of belief, or sufficient facility with it, be able to represent how things appear, cognitively speaking, from a vantage point that diverges from their own. FB tests have been greatly popular because they provide psychologists with a well-defined yet modifiable experimental protocol that can be applied to different populations, across species, and in diverse settings. In their 2001 meta-analysis focusing on experiments conducted before 1998, Wellman, Cross, and Watson 2001 reviewed 178 such studies, conducted in 591 conditions. A standard assumption in developmental psychology has been that something important happens in the normal pattern of child development somewhere between the ages of 3 to 5. These are the ages around which FB understanding is usually thought to be acquired by most normally developing children, Astington 2001, Wellman and Liu 2004. Indeed, for many, the passing of FB tests is thought to tell us something important about a subject's TOM abilities. Some hold that success at FB test is the mark of a subject having acquired the final component of their mature TOM. The tacit assumption made here is that children put the finishing touches on their FP competence by mastering the concept of belief. There are two things to note concerning these assumptions. Firstly, empirical studies of characteristic developmental patterns have focused almost exclusively on subjects from weird Western, educated, industrialized, rich, and democratic societies, and, as such, conclusions drawn from them should be treated with caution. Henrik, Heine, and Norenzayan 2010. Secondly, even in industrialized Western populations, the full suite of standard FP abilities is not securely in place in children's performance until after the ages of 5 or 6. Summarizing a range of empirical findings, Apperly and Butterfield 2009 report that even older children who are capable of passing false belief tests still have problems understanding how beliefs are acquired, how beliefs interact with desires, and in anticipating the emotional consequences of false beliefs. In recent years, new kinds of FB tests experiments have shown that children as young as 25 months, Southgate, Senju, and Chibra 2007, 15 months, Onishi and Balarjan 2005, and 13 months, Surian, Kaldi, and Sperber 2007, can pass language-free versions of false belief tasks. Taken at face value, the new infant data suggests that very young children must have some command of the concept of belief, even though much older children lack, as we have seen, the capacity to pass standard, verbally based, FB tasks. These findings have led to the articulation of the so-called developmental paradox, Southgate 2013, De Bruin and Nguyen 2014. Why is it the case that cognitively typical 3 to 5-year-old children struggle with explicit FB tests if they are already competent with FP at much younger ages? Some T-tests seek to explain the evident developmental changes in children's conceptual abilities without the need to posit any radical change to or development of TOM concepts. These T-tests propose that children do not change the conceptual components of their TOM. These T-tests hold that children operate with one and only one TOM with the same basic concepts throughout their entire lives, from early infancy to adulthood. Belargin, Scott, and he 2010, Scott and Belargin 2017. T-tests of this stripe claim that the developmental paradox is an illusion. By their lights, the core concepts of FP never change even though the capacity to apply concepts comes in degrees. The variation in children's performance, they propose, is the result of other complicating factors, such as the development of executive function capacities, working memory, and language abilities. On this view, the failure of explicit, verbal false belief tasks does not reveal a conceptual deficit, rather it reveals a deficit of performance rather. Competence. Carruthers 2013, 2016, Belargin, Scott, and Bian 2016, Schonher and Westra 2019. An alternative TT proposal is that we can beset explain the aforementioned developmental changes in humans by positing the existence of two functionally distinct TOMs. On this theory, one type of TOM underwrites adult FP capacities to ascribe propositional attitudes. Yet we also make use of a more minimal TOM, one which employs and attributes weaker concepts than that of belief proper. This second, earlier developing TOM is, ex hypothesi, used for fast and efficient, but limited TOM tasks. Apperly and Butterfield 2009, Butterfield and Apperly 2013. On this dual TOM theory, our first TOM never grows up. Instead, radically new concepts and principles come into play with the advent of our adult TOM, which arrives at around ages 3 to 4 in normally developing Western populations. After that point, both TOMs begin to work alongside one another. Neutrally presented, the findings of FB tests do not automatically support TOM interpretations. What the FB data shows is that before a certain age, which varies considerably with individual differences, children are unable to make correct belief attributions or to correctly answer questions about belief-related actions when this requires them to specify the content of the divergent cognitive points of view of others. All such tests confront children with a task that inherently demands that they adopt a spectatorial stance. Consequently, the experimental data provide no direct insight into the true range of children's FB understanding. Nor do they reveal what role such FB understanding might play in children's ability to make sense of others in more natural and less restricted interactional settings. Reddy and Morris 2004, Buttleman, Carpenter, and Tomasello 2009. It has been argued that FB tests do not probe deeply into the child's FP understanding because they only test for such understanding in third-personal, experimental conditions. Such tests leave us none the wiser as to how frequently or centrally such FB understanding is used, how the children come by it, what enables its acquisition, which other tasks it might be used for, and so on. Several psychologists and philosophers have emphasized the artificiality of FB experiments and the contrived nature of the situations, those requiring subjects to take up a third-personal stance on others, in which they are conducted. These critics of FB testing conclude that while FB tests allow for the focused collection of data, that collected data tells us precious little about the use of FP in everyday human social engagements, namely those we find, in the wild, and, in the streets. Gallagher 2001, 2015, Ludar, Kostal, and Francis 2004, Ludar and Kostal 2009. Given the limits of the FB experimental protocol, it has been argued that such tests do not tell us much about children's FP capacities in other, more ecologically valid contexts and settings. 3.3 Neuroscience. A great deal of experimental work has been devoted to identifying the dedicated brain regions or network of brain regions that are reliably involved in TOM tasks. See Koster, Hale and Sachs, 2013 for an overview. This empirical work usually takes the form of correlative fMRI neuroimaging and transcranial magnetic stimulation, TMS, studies. Schuerk, Languth, and summer 2014 report on findings that have been employed using both of these methods to test a diverse range of subjects of different genders, ages, and cultural backgrounds. Based on accumulated evidence, it is now claimed that 5 regions of the brain are specifically and reliably active in TOM tasks. These regions have been identified as 1. The left and right temporoparietal junction, LTPJ and RTPJ, 2. The left and right dorsolateral prefrontal cortex, DLPFC, 3. The left inferior frontal gyrus, IFG, 4. The ventral medial prefrontal cortex, VMPFC, and 5. The posterior medial prefrontal cortex, PMPFC, Schurk et al. 2014. The idea that mind reading involves a large-scale network respects a Perlez 2010 warning against overemphasizing the importance of any single brain region and assigning it the function of mind reading, per se. Focusing too narrowly on single brain regions, it is argued, overlooks the importance of a broader set of neural regions that must work together in concert, on the assumption that many such regions serve their own important or even indispensable mind-reading functions. Data-driven meta-analyses of networks seek to reveal the more specialized functional contributions of specific brain regions within a broader neural network. For example, it has been claimed that TMS studies can identify the specific contribution of particular regions to overall TOM tasks, Colby et al. 2010. Reportedly, TMS studies suggest that the medial prefrontal cortex, PMPFC, for example, plays a part in enabling subjects to distinguish their perspective from that of others. By contrast, other findings suggest that the RTPJ brain region is selectively enlisted for tasks requiring the interpretively complex attribution of mental states to others. Mehi, Moses, and Pfeiffer 2014. For example, Sachs and Wexler 2005 found that RTPJ activity is increased compared to other regions. This happens when the professed beliefs or desires of story protagonists conflict with a subject's background expectations about what these characters ought to believe or desire. Moreover, this region is not similarly recruited for other tasks that involve assessing other, more general, socially relevant facts about persons. Importantly, it appears that the relevant selectivity of this brain region comes late in the day, emerging, in the RTPJ between ages 6 and 11 years, Sachs 2009, 1206. Citing work by Kobayashi, Glover, and Temple 2007, in their systematic examination of the neural evidence of major theories of TOM acquisition, Mehi, Moses, and Pfeiffer 2014 also emphasize that, although 8 to 12-year-old children significantly engage TPJ bilaterally in TOM stories, younger children do not always show this selective TPJ recruitment. 2014. 70. There is some consensus that the TPJ is recruited and involved in FP modes of understanding minds in later stages of development. There is also evidence that there is no single, dedicated neural network at play in TOM-related tasks across all stages of development. Guian et al. 2012. In a bid to make sense of these findings, Sachs and colleagues take seriously the recent hint that middle childhood is a critical time for interactions between language and theory of mind. Sachs 2009, 1207. These findings present a prima facie challenge for approaches that assume TOMs are innate and early maturing. See Sachs 2009, Mehi, Moses, and Pfeiffer 2014. Importantly, it is worth noting that even the TPJ is not deployed only or solely in TOM tasks. Commenting on this lack of specificity problem concerning the TPJ, Apperly 2010 reports the following conclusions reached in a meta-review of neuroimaging studies. The so-called mind-reading network was implicated not only in mind-reading tasks but also in tasks involving information recall, general reasoning, and inductive reasoning in uncertain conditions. It turns out that many tasks that do not appear to inherently involve TOM nevertheless evoke activity in the TPJ, violating the specificity criterion. See Mehi, Moses, and Pfeiffer 2014. Some, such as Rosenberg 2018, are sanguine that, taken together, the neuroscientific findings provide evidence that the theory of mind is localized to a small number of specific brain regions acting together as a mental module. 2018, 60. These considerations also allow for the possibility that mind reading is, at best, enabled by a loose confederation of brain areas that pull together in wide-scale networks to complete TOM task as opposed to consisting of a stable dedicated brain network. Anderson 2014. TOM-focused neuroscience is still developing. A recent verdict on the state-of-the-art summarizes the current situation. Although functional neuroimaging techniques have been widely used to establish the neural correlates implicated in TOM, the specific mechanisms are still not clear. Zheng et al. 2020. 1. 3.4 Cross-cultural psychology. Many studies in cross-cultural psychology reveal apparent socio-cultural variation in FP and FP-related abilities, e.g., Avis and Harris 1991, Vinden 1996, 1999, 2002, Naito and Koyama 2006, Liu et al. 2008. These empirical results suggest there may be important differences between the forms of FP used in different cultures. Mills 2001. Assessing a body of cross-cultural data relating to FB tests, Mayer and Traubel 2013 reach the cautious conclusion that it is not clear whether it is justified to assume a universal onset of false belief understanding across cultures. 2013. 22. Plenty of cross-cultural variation has been found when comparing non-Western and Western societies concerning other aspects of FP-related understanding. The standard explanation for such differences is put down to the fact that the early social experiences of children in such societies clearly differ from the experiences of children in Western cultures. Mayer and Traubel 2013. 22, Barrett et al. 2013a, 2013b. Consider, for example, Mayer and Traubel's 2013 study of the onset of FP understanding in Samoan children. Like other cross-cultural researchers, they choose to look at this particular population precisely because ethnographical work reports different practices of intersubjective understanding. Mayer and Traubel 2013, 22. A plausible explanation of differences in the timing of the emergence and application of FP-related abilities in the Samoan case focuses on how, and how frequently, mental states terms are used in that culture. As cultural anthropologists and ethnographers observe, it is widely asserted in societies of the Pacific that it is impossible or at least extremely difficult to know what other people think or feel. Robbins and Rumsey 2008, 407-408. A possible explanation of Samoan FP-related tendencies is that mental states are talked about less frequently and in different ways in Samoan populations than they are in populations with other socio-cultural practices. Another line of research reveals that belief understanding varies in certain Eastern populations, Hong Kong, Japan, when compared with their Western U.S., Eastern Europe counterparts. Doan and Wong 2010, Liu et al. 2008. Again, this difference may be connected to the fact that different explanatory practices prevail in these societies. Chow 1994, Bradford et al. 2018. Fibich 2016 proposes that these cultural differences are evident in early mother-child conversations. Caretakers from Western cultures seem to favor mentalistic narratives, whereas caretakers from Asian cultures exhibit a preference for behavioral contextual narratives. For example, when reading a picture book together with their child, European and American mothers tend to refer more often to the mental states of the protagonist, e.g., the bear is sad, rather than to the embodied aspects of those states, e.g., the bear has tears on his face, in contrast to Chinese mothers. This correlates with earlier evidence that suggests children from several non-Western cultures do not employ the familiar Western FP schema, or at least that they do not do as readily or with the same proficiency as Westerners do. Vinden 1996, 1999, Lillard 1997, 1998, see also Lavelle forthcoming. Other cross-cultural evidence reported by Wellman and Peterson, 2013, found variations in the developmental sequence in which the component elements of FP competence are acquired. They observe people can understand other minds in terms of a range of attitudes, including diverse desires concerning the same object, diverse desires, DD, different beliefs about the same situation, diverse beliefs, DB, that something can be true while the person may not know that, knowledge access, That something might be true while the person believes otherwise, false belief. FB, and that someone can feel one way but display a different emotion, hidden emotion, he. The order and sequence in which children get a grip on different attitudes vary socio-culturally. Based on a series of studies involving over 500 preschool children in the USA, Canada, Australia, and Germany, it was found that 80% of children exhibit a common pattern of acquisition, developing their FP-related understanding in the following sequence: DD greater than DB greater than CA greater than FB greater than he. However, it has been discovered that Chinese and Iranian preschoolers come by their FP understanding in a different order, acquiring CA competence before DB. Shahayan et al. 2011. Wellman et al. 2006. Wellman 2011. Once again, a possible explanation of these differences ties them to local conversational cultural preferences. Taken together, these findings suggest that not all cultures engage in all the same FP practices, nor do they do some in the same sequence or the same way. Evidence gleaned from the handful of cross-cultural studies that have been conducted suggests that neither full FP understanding nor mastery of the concept of belief comes automatically or in equal measure to all members of the human species. Looking at the practices of other cultures, there is apparent heterogeneity in the explanatory tendencies and methods used in making sense of people's actions. In some parts of the globe, great emphasis is placed, for example, on situational, trait-based, and even supernatural explanations factors. Morris and Pung 1994, Lillard 1997, 1998. The accumulated cross-cultural evidence should make us cautious in assuming that all human populations exhibit the same kind of FP understanding or use FP to the same extent or for the same purposes. 4. Philosophical challenges to theory. 4.1 Eliminativism. T-ists assume that mature scientific psychology and FP both offer up theories that are in precisely the same line of work, namely, that of causally explaining behavior. Yet, to the extent the mature scientific psychology and FP compete in this domain, the latter looks like a poor contender. Good theories run deep. They are based on hard-won knowledge of underlying causes rather than on generalizations based on surface data. Good theories provide a powerful means of anticipating, explaining, and controlling what happens. They do so by tapping into the world of the unseen and the abstract. A good theory allows us to make solid bets that pay off quickly and selectively, using minimal evidence. Good theories reliably guide expectations, even in novel circumstances. The key question then is, if FP is a theory of everyday human psychology, is it a good theory? Some argue, given what we already know and are likely to discover, that is almost certainly a false theory. Some think it is so poor that we have reason to think the states over which it quantifies do not exist. Going by Churchland's 1981 assessment, we have every reason to think FP's principles are false and its ontology is an illusion. Churchland 1979, 1989, 1993 highlights FP's lack of unity and fit with a growing body of theory elsewhere in the sciences. Others agree. Rosenberg 2018, for example, maintains that modern neuroscience directly refutes FP proposals about the true causes of human behavior. Without the benefit of a sustained and thriving scientific research program, FP seems to be, at most, a low-grade theory that is in tension with the best theories of mind that the mature cognitive sciences are developing. Many suppose that the advancing theories of cognitive science and neuroscience offer a deeper and more accurate means of understanding mind and cognition. See Carruthers 2011, Hayes 2018, Rosenberg 2018, see Horgan and Woodward 1985 for a defense of FP on this score. It has been argued that as long as we assume FP is any kind of Tom, then it won't remain in the theoretical running unless it allows for revision and is prepared to incorporate the latest findings of mature scientific theorizing about minds. Murphy 2006, Garance 2014. Assuming FP is not open to such significant, open-ended revision, Churchland 1989 famously characterizes it as a stagnant or degenerating research program. Eliminativists regard FP's theoretical commitments as backward and outdated. FP is often compared to rejected theories that sought to explain diseases by appeal to witches as opposed to germs. Importantly, a Tom can be an imperfect, false theory that fosters only illusions even if it is hardwired in our brains. If so, FP is a bad theory that we, as a species, may find it hard to shake because we are universally preset to acquire it due to its quick and dirty utility in everyday contexts. Other reasons have been offered for thinking that FP is an inferior theory when compared to the theories of scientific psychology. It has been argued that the contents of propositional attitudes are necessarily world-relating in a way that requires us to look beyond the bounds of an organism's skin when assigning contents to such attitudes, Stitch 1983. On this analysis, the ways we attribute mental state concepts and contents involves recourse to similarity conditions and normative principles of charity that could not possibly feature in a mature science of the mind, Davidson 1984, 1987. On this view, FP involves the ascription of contentful attitudes by employing interpretive methods that are inescapably bound up with norms of rationality. For those persuaded by such arguments, to the extent that FP is properly characterized as a theory at all, it must be regarded as a domestic theory of very limited scope, one that is unfit to predict or explain the behavior of exotic subjects, such as very young children and animals, Stitch 1983. If this analysis is correct, it reveals FP to be inherently wedded to an explanatory schema that is incompatible with the demands of serious scientific psychology. To the extent that FP embeds such features, it breaks faith with the alleged central tenet of any bona fide scientific psychology, namely, that proper causal explanations should only cite proximate causes of action, those located physically, inside the skin of agents, Fodor 1981, McGinn 1989. For those persuaded by this line of argument, FP will be incapable of providing causal explanations of action if it turns out that the content of propositional attitudes needs to be individuated by factors that necessarily require looking beyond an agent's skin. 4.2 Simulation Theory. Since the mid-1980s, the main rival to TT has been the simulation theory, or ST, of which there are many varieties. The major proponents of ST diverge in their views about what exactly simulation involves. They heterogeneously characterize the process of simulation as a form of imaginative transformation, Gordon 1986, 1995, 1996, thought replication or co-cognition, Heel 1986, 1995, 1996, 1998a, 1998b, introspective modeling, Gopnik and Wellman 1992, and offline practical reasoning, Goldman 1989, 2006. Simulation theorists take it for granted that we regularly engage in FP, but they hold that doing so does not imply the existence of a set of conceptually articulated TOM principles. They propose that as our minds are already populated with the relevant mental states and that we can systematically manipulate those mental states in precisely the sorts of ways TT principles aim to describe. Proponents of ST also propose that when we make mentalistic attributions to other minds, we use our minds as models for those targets. Thus, even though the simulation process is a structured activity involving the attribution of mental state concepts, no theoretical principles need to be consulted or used when we understand minds in FP fashion. Goldman 2006, for example, depicts high-level mind reading of the sort associated with FP understanding as a three-stage process. In the primary or preparatory phase, appropriate targets must be identified, viz., intentional actions are what at least looks to be such. During the second, or what might be called the simulative phase, appropriate inputs, pretend, thoughts, beliefs, or desires, or the same entertained hypothetically, are fed into specific subpersonal mechanisms, e.g., the practical reasoning mechanism operating in an offline mode. These mental states are then internally manipulated to yield predictions or explanations. Mentalistic concepts are not needed for the first two stages of the process, but they come into play when attributing mental states to targets in the final phase. Making such attributions requires identifying which mental states it is that one is ascribing. These must be classified both by appeal to their general attitudinal type, belief, desire, hope, and their specific content, e.g., that the bus leaves from stand 25. To the extent that simulation processes might exhaustively explain our FP abilities, ST directly challenges TT explanations. ST offers to explain how FP ascriptions can be carried off without positing any kind of theory as being involved in the central mind-reading process. Motivated by the acknowledgement of some limitations of pure TT accounts, see Heal 1998a, 1998b, some TTists have come to favor hybrid explanations of the cognitive basis of FP in which both theory and simulation have clear-cut parts to play in achieving FP understanding, Goldman 2006. Yet however this alliance is precisely conceived, there remains a crucial question about which, if either, of the two theories, TT or ST, does the work of explaining the core structural aspects of RFP competence. See Apperly 2008 for a critique of the explanatory value of both approaches. 4.3 Phenomenological critiques of TT. Several authors, drawing on phenomenological considerations, offer a fundamental critique of all variants of TT, arguing that TT approaches systematically mischaracterize their target explanandum in crucial respects. Gallagher 2001, 2020, Ratcliffe 2007, Gallagher and Zahavi 2008, Gallagher and Hutto 2008, see Hutto and Ratcliffe 2007 for an overview. Such critics maintain that the way we engage with and understand others in everyday life is misdescribed when they are depicted as being essentially theoretical. These philosophers challenge the idea that interpersonal engagements of the sort that are meant to be captured under the FP umbrella are a matter of seeking to infer the underlying causes of another's behavior by means of mental state attribution. Phenomenological reflection, they argue, speaks against the TT assumption that our situation with respect to others is fundamentally that of a scientific spectator to target phenomena. That TT assumption is fostered by thinking that if we are to understand other minds we must bridge an assumed epistemic gap that exists between us and others, and that we must bridge that gap by accurately depicting the mental states that move others to act. It has been argued that modeling FP on a scientific enterprise paints a distorting picture of its character. Positively characterized, our everyday ways of engaging with and understanding others are said to be a matter of responding directly to the attitudes and emotions of others, making sense of their projects and commitments, and trusting or not trusting the accounts they give us about why they do what they do. Phenomenologically motivated critics of TT argue that when we deal with others in these kinds of ways we do not take up a scientific stance towards them. These phenomenologically motivated critics deny that TT provides an accurate description of what we do when we make sense of actions in everyday life. Hirschbach 2008, Strybos and De Bruin 2012. For example, often when we are interested in another's reasons for acting, we get at their reason by being told directly why they acted thus, and so those second personal exchanges, obviating the need to infer or attribute mental states to the other. Hutto 2004, 2008. To understand FP exchanges of this kind aright is, in McGeer's words, to recognize that we do not interact with one another as scientists to object, as observer to observed. 2007, 146. The most radical phenomenologically motivated challenge to TT holds that when we look closely at how we understand one another in everyday life we do not find people making mental state attributions of standard FP sort at all. Ratcliffe 2006, 2007. Defending this analysis, Ratcliffe offers a deflationary appraisal of FP, regarding it as a kind of philosophical fiction. By his lights, FP is a misleading picture of our everyday ways of understanding one another, a picture that lacks depth and which does not come close to the richness of our actual practice. 4.4 Pluralism. Up until the 2000s, it was the received view that FP abilities were based, wholly or primarily, in mind-reading abilities, and that such abilities were assumed to be best explained by TT, ST, or some hybrid combination. That orthodoxy has been challenged by pluralists about FP who maintain that we engage in FP for many purposes other than prediction and explanation. For example, it has been proposed that FP enables us to coordinate, justify and regulate our actions and behavior. FP pluralists maintain that we achieve these diverse ends by diverse means and methods. Bermudez 2003, Slors and MacDonald 2008, Andrews 2008, 2012, Fibich, Gallagher, and Hutto 2016, Andrews, Spalding, and Westra forthcoming. A signature pluralist assumption is that the extension of FP is wider than traditionally supposed, encompassing anything we do when understanding minds and navigating everyday interpersonal relations. See Hornsby 1996, Spalding 2018b. According to FP pluralists, there are many ways that we keep track of and think about minds. Our methods for doing so are not exclusively restricted to attributing mental states but include being sensitive to a range of factors including socio-cultural situational norms, conventions, stereotypes, implicit biases, and person-specific character traits. How we think about minds on any given occasion, pluralists claim, varies as a function of context and our shifting FP goals. Some variants of FP pluralism are perfectly compatible with TT. They assume that the use of Tom lies at the core of FP understanding and that a Tom interacts with and is informed by other kinds of information concerning the aforementioned range of socio-cognitive factors. Spalding 2018a, 2018b, Westra. 2018, 2019, 2020. Other versions of FP pluralism do not give TT pride of place as FP's primary or default function. Some variants place TT predictions and explanations on equal footing with other FP methods and goals. FP pluralism of this kind assumes that FP has no single primary function or method. Rather, FP uses various means to achieve multiple ends, such as making and justifying moral judgments, fostering social bonding, molding, and regulating behavior. Yet other versions of FP pluralism directly threaten TT by assuming FP has a primary function and basis that is non-theoretical. Such accounts reject TT by holding that FP's primary function is not that of making third-personal predictions and explanations about minds. For example, it has been proposed that FP's primary work is to achieve regulative mind shaping by means of imitation, pedagogy, and other social conformity mechanisms. So understood, the main work of FP is that of normatively molding, not descriptively reading. Minds. McGeer 2007, 2015, forthcoming, Zawadzki 2008, 2013, Castro 2020. It is assumed that as a result of such mindshapping minds become more predictable, enabling, amongst other things, successful cooperation and the successful predicting and explaining of minds by attributing contents to them. Importantly, on these mindshapping accounts, anything we might call theorizing about minds is a parasitic and peripheral capacity that only comes into play in special contexts. 4.5 The Narrative Practice Hypothesis. Alright, let's break down the Narrative Practice Hypothesis, NPH, in simpler terms. Imagine folk psychology as a kind of storytelling. We use narratives to understand why people do what they do. Instead of relying on theories or mental models, the NPH suggests that our understanding of actions is shaped by engaging in storytelling activities. In these stories, we talk about not just beliefs and desires, but also hopes, fears, emotions, and even a person's history and character traits. The NPH says that to fully understand someone's actions, we need to know more about their story, their background, experiences, and the social context in which they act. Unlike other theories, the NPH doesn't see prediction and explanation as symmetrical, meaning, understanding why someone did something isn't just about predicting their actions based on past behavior. Instead, it's about interpreting their actions within the larger context of their life story. According to the NPH, our understanding of folk psychology isn't based on internalized rules or theories stored in our brains. Instead, it comes from interacting with the narratives around us, stories shared by our culture and caregivers. These narratives shape how we think about and understand human behavior. So, in a nutshell, the NPH says that our ability to make sense of actions isn't about theories or mental models, it's about storytelling and understanding people's lives in a broader context. Thank you for watching our video.